Hello everyone, and welcome to the NEATEC Electronics Series. This episode is about digital arithmetic, so let's get started. Alright everybody, so let's talk about digital arithmetic, shall we? The first thing we need to discuss is signed versus unsigned binary numbers. Alright, this is not a hard concept really, but basically if you have a number that's 8 bits long, okay, there you go, right? And this is an unsigned number. That means every bit will count towards the actual number, and it's going to be assumed that it's a positive number. Okay, so if you look at it, this is the ones, this is the twos, fours, 8, this is 16, 32, 64, 128. So you could go up to 256, right? Actually 0 to 255 of an 8-bit unsigned binary number, right? Now, if you have a signed number, this is your most significant bit right here, okay? It's on the left. This is your most significant bit, okay? Obviously, if that's the most, this is your least significant bit on the right, right? But this most significant bit for a signed binary number is the sign bit, okay? I'm going to draw it again. This is the sign bit, all right? So basically, if your sign bit is a 0, this means you have a positive number, and if it's a 1, that means you have a negative number. Alright? So obviously we're going to discuss this more in the future, but I want to make sure you have a basis for understanding the difference between signed versus unsigned numbers. Okay? Alright, I'll be right back and we'll start talking about binary addition. See you in a minute. Alright everyone, so now we're going to talk about addition. Okay? Now, I've written the rules basically for addition over here, and they may not make a whole lot of sense to you right now. And the best way that I've found to learn this is actually through example. So I have two examples here, two binary additions we have to perform, and when we're doing that I'm going to refer back to this table, alright, so it'll help you understand what it means. Okay, so first off, let's do this one over here on the left. Okay, when you perform a binary addition, you always start at the right and you move to the left. Okay, you move that way. So the other thing is, when I do it, I like to fill out the bottom, if it's short like this, with zeros, so both numbers have the same number of bits. Okay, now let's start here. We have 0 plus 0, right? Now what does that equal? If we come over here to this line right here, it says 0 plus 0. The sum is equal to 0. Alright? By the way, I should have written this down. This is your sum, okay? That's the sum symbol, okay? That's your sum line, okay? And up here, this is going to be your carry, okay? So 0 plus 0, your sum is equal to 0, which we filled in, and your carry is also equal to 0, right? So here's your carry, right? Now let's perform this addition. You have 0 plus 1 plus 1. Well, it looks like now we're going to look right here, isn't it? If we look at 1 plus 1, which is what we have, 0 plus 1 plus 1, your sum is equal to 0, so your sum would be equal to 0, and your carry would be equal to 1. There's your carry, right? Now we're in this column, so we have a 1. I'm just going to put a little mark here so you can see the column we're at. So we have a 1 plus a 0 plus a 1. Well, it's the same thing, right? It's a 1 plus a 1, isn't it? So sum is 0, carry is 1. Get it? Now we have a 1 plus a 1 plus a 0. Well, it's still using this rule, isn't it? So your sum would be a 0, and your carry would be a 1, wouldn't it? And now you have a 1 plus a 1 plus a 0. Same thing, right? Using the same rule, this would be a 0, and then we have a carry over here. Looks like we ran out of bits, didn't we? And 1 plus a 0 plus a 0, well, basically we're using this rule right here. 1 plus a 0 is equal to a sum of 1 and a carry of 0, okay? 0 would be over here if you're going to want to write it, but there's no other bits, so it really doesn't matter, right? So look at what we have. We have 1, 2, 4, 8, 16. This is 32. Got it? This is equal to 32 base 10, right? Well, let's just check our work. What is this, right? This bottom one equal to? It's equal to 1, 2, 4. So this is equal to 6, isn't it? And this number, and 6 base 10, I'm sorry, I should say. And what's this equal to? Well, it's going to be 1, 2. We have a 2, 4, 8, and 16. So 2 and 8 is 10, and 16 is what? 26, right? Base 10. So 26 plus 6 is 32, and that's what we came up with, right? So it works, huh? All right, let's try another one, shall we? Why don't you try this one? I'm going to move it over just a tad for you. Why don't you try this one on your own? Pause the video, and then when you're done, restart the video, and we'll do it together, okay? All right, everyone, so let's do it. And let me do some erasing over here. That was from the other problem. Let's do this one. So now we have a 1 plus a 1, right? We're starting in the least significant bit column, right? It's the one farthest to the right. So a 1 plus a 1, that is this column right here. What's that equal to? 1 plus a 1 is equal to a 0. You carry the 1, right? Now we have a 1 plus a 1 plus a 1. Looks like we're going to use this rule, aren't we? That means the sum is equal to a 1 and the carry is equal to a 1. Get it? Now you have a 1 plus a 1. That's this rule again. That means your sum is going to be 0. Carry is going to be a 1. Then you have a 1 plus a 0 plus a 1. Again, you can use this rule right here, the sum is going to be a 0. Carry is going to be a 1. I'm going to bring this out a little bit to make sure they all have the same number of bits. I should have done that in the beginning. I'm sorry if I confused you there. So here we have a 1 plus a 1. It's the same rule. We're going to have a sum of 0, a carry of 1. I'm going to have to bring these out a little bit so the bits, there's bits there. And that is a 1 plus a 0 plus a 0, which is going to use this rule. That's going to be a sum of 1 with a carry of 0, right? So what's this number? Well, this is 1, 2, 4, 8, 16, 32. So this is going to be 34 base 10, isn't it? Well, let's check our work, shall we? What's this? This is a 1, a 2, that's 3. 1, 2, 4, 8, that's going to be 11, isn't it? Base 10. And the upper one is going to be a 1, 2, 4, that's 7, right? 8, 16, what's 7 and 16? That's going to be 23. Base 10, isn't it? We add them together, you get 34. Looks like it works, right? So this is the basic method of performing digital arithmetic. Just add two numbers at a time. And remember, you have a sum area and you're going to have your carry region here, right? Your carry, that's your sum. And if you have 4 numbers or 3 numbers you have to add 2 of them. You come up with a number and then just add that to the next number and the next number and the next number. You just keep going through it. Alright? But if you add 2 numbers at a time, you can add as many binary numbers as you like. Okay? Alright, everyone. Next, we're going to talk about binary subtraction. See you in a minute. Alright, everyone, let's talk about subtraction, specifically binary subtraction, okay? So, I've written some rules down over here, alright? And you might not quite understand them right now, but if we go through an example, I think they would become more clear to you, alright? So let's just use this as an example. Let's just dig right in. So again, I like to make the numbers have the same number of bits. And this is called padding. If you add zeros to the left side, you're padding it just to have it have the same number of bits. That's all. So let's try it. We're going to go from the right to the left, just like we did in addition. We're going to be going each column. We're going to be going that way, right? So, sorry about that. Put that 0 back there. So this is 0 minus a 0, right? Well, if we look at this one, 0 minus 0 is equal to 0, right? Probably everybody doesn't have any problem with that. That's good. And if you do, talk to your instructor. I'm sure they could help you with that. Now, let's move on to the next column. Now we're working on this column right here. All right? We're trying to subtract this number 1 from a 0. We can't do that. All right? Obviously, we have to borrow. So we're going to come over here. I'm going to change colors now into blue because I want to emphasize this. We're going to change this. We're going to borrow 1. So this now becomes a 0, right? And we're going to put a 1 there. Got it? Now, I'm going to change colors on you again. We're going back. If we use this rule, This is a 1, 0 minus a 1. That's equal to a 1, isn't it? Got it? Now, what do we have here? A 0 minus a 1, just like before. Can we do that? Obviously not, right? We have to borrow. Can we borrow from this column? No. Can we borrow from this column? And the answer is yes, right? Here we go. This becomes a 0, all right? That becomes a 1. And we're going to have a 1 here. Now, I want to go over this, all right, because there's several different methods of teaching this, and I want to make sure you understand it. I'm going to redraw this upper number right here, 1, 0, 1, 0, 0. Now this one are done. We already did those. So this had become a 0, didn't it? And we're trying to subtract a 1 from it, aren't we? Well, we need to borrow, and we're borrowing it way over here, right? We're borrowing it from way over here. Now, if you recall, and by the way, let's just put this 1, 0 right here. If you recall, each of these columns corresponds to a specific number. This is the 1s, this is the 2s, this is the 4s, this is the 8, and this is the 16, right? Now, that was a 1 and that was a 0, I believe. I just put it in there. So, if we're going to borrow from here, this 16, make it a 0, that's basically equal to 2 8s, right? Got it? That's not the number 11. That stands for basically 2 8s. It's a 1 1. Okay? Now, we have to keep borrowing it, right? Because we have to, it has to come over now to this side, right? Because that's where we need it. Well, one of these 1s is going to be lost, so that'll go. And this side has a 1 and a 1, right? Because this is an 8. 1 8 is equal to 2 4s, right? So we have a 4 and a 4. Just 2 of them, right? Now, you have 2 4s up here and up in this row, and you have 1 4 down here. Well, think about it. One of these 4s, this 4 is going to consume this 4, so you'll have 1 4 left over, won't you? Hence, that is how you get your 1 below. Got it? I just drew it on that side. I'm trying to give you some understanding of where this comes from, because this kind of gets confusing to folks, okay? So then if we continue, now I'm going to shift efforts back here, and don't worry, we're going to do another example, okay? Now, we're on this column right here. We have a 1 minus a 1, that's going to be a 0. And we have a 0 minus a 0, which is going to be a 0. Okay? So, let's think about what this was initially, okay? Let's see if it's right. This is going to be the number 6 base 10, right? 1, 2, 4, that's 6 base 10. What was this number? 1, 2, 4, 8, 16. So this was the number 20 base 10. And this was 1, 2, 4, and 8, 6 and 8. This was the number 14 base 10, right? So 20 minus 14 is equal to 6. So it worked. Alright everyone, let's try another one. By the way, subtraction can get a little bit more confusing than the addition, okay? So if this is taking a little more time to understand, don't worry about it. It's perfectly normal, right? So let's try another one. Let's say we're going to subtract 0, 0, 0, 0, 0, what is that, 4, 5, 6, 7, 8, alright? And we're going to subtract, I know, 1, 0, 0, 0, 0, 0, 0, 0. Got a subtraction. Alright, give this a try, and then pause the video, give it a try, and then when you're ready, just restart the video and we'll do it together. Alright everyone, let's give this a try, shall we? So we have 0 subtracting 1. Can we do that? That's a big resounding no. Okay, so we have to borrow. So if you look over here, there's nowhere to borrow from except here, isn't it? So we're going to make this a 0. Alright? That's going to equal 2 1s in this column, isn't it? Well, one of these 1s is going to be lost. It's going to equal 2 1s in this column, isn't it? Well, one of these 1s is going to have to be borrowed, so we're going to 2 1s in this column, isn't it? Well, that 1's going to be consumed. We're going to 2 1s in this column. Well, that 1 you're going to go lose. It's going to have 2 1s in this column. One of those 1s is going to be gone because they're going to be 2 1s in this column. These 1s is going to be gone, so you're left with 2 1s over here. Well, you have 2 1s here, and you're subtracting 1 1 here, so this 1 is going to consume that 1, and you're left with 1, so that's going to be a 1. Again, that's this right here, okay? Now the rest of these, you're going to have a 1 minus a 0. That's this one right here, isn't it? That's equal to a 1, isn't it? So these are all consumed, right? So we really don't even need these listed anymore. They were consumed because they were borrowed. Right? So if you look at all of these 1s, I didn't cross these out when I was borrowing, I'm sorry. But these are all replaced, right? So you have a 1 minus a 0, that's a 1. A 1 minus a 0, that's a 1. It goes all the way along. 1 minus 0, 1 minus 0, 1 minus 0. And here you have a 0 minus a 0, which is a 0, right? So just looking at this makes perfect sense. Because this number, 1, 2, 4, 8, 16, 32, 64, 120, this number was 128. You subtract 1, this number is 127. Alright? Because you just subtracted 1 here, right? 128 minus 1 is equal to 127. So it works, huh? Alright everyone, let's do one more, shall we? I hope this is making sense to you. takes some time. So let's try this one. 1, 1, 1, 0, 0, 1, 1. Okay? And then we want to subtract 1, 0, 1, 0, 0, 1, 1. We're going to subtract it. Okay, everyone, pause the video and give it a try. And then when you're ready, turn the video back on and we'll do it together. All right, everyone, let's give it a go, shall we? 1 minus 1 is a 0. Okay? 1 minus a 0 is a 1. 0 minus 1 we can't do. 0 minus 0, well, we can't. We've got to borrow to do this, right? We can't borrow from here. We've got to borrow from here. So this becomes a 0. 1, right? 2 1s. 1's consumed. We're going to have 2 1s over here. This one consumes this one. So we have a 1 left over, right? 1, by the way, that should go away. Sorry. 1, right here you have a 1, right? A 1 minus a 0 is a 1. 0, or here. 0 minus 0 is 0. 1 minus 1 is 0. And 1 minus 1 is 0. All right. So let's just do what we normally do. Let's just check our work, shall we? So what's this number? This is going to be 1, 2, 4. That's a 5, isn't it? 5. 1, 2, 4, 8, 16. 32 and 64. 32 and 64 is 96. 96 plus 5, that's 101, isn't it? Base 10. What's this one? This is going to be 3, 1, 1. That's the number 3. 1, 2, 4, 8, 16, 32, 64. So what did we say? 32, 64 is 96 plus 16, right? 96 plus 16 is, that's 112, I believe. And 112 plus 3 is 115, isn't it? Is that right? 3, 1, 2, 4, 8, 16, 32, 64. That's 96. That's 106. So that's 112. 112 plus 3 is 115. So if you subtract that, you should have 14 left. 14 base 10, right? Well, what do we have here? 1, 2, 4, 8, right? Well, 2 and 8 is 10 plus 4, that's 14. 14 base 10. What do you know? It matches. It works. Now the best way to learn this is by practice. Alright? So keep practicing and I'm sure you'll get it. Alright. Now, next we're going to continue the discussion about subtraction. However, in most electronics, this kind of subtraction is not performed. Instead, you add a negative number to another number. Okay? So we're going to learn about 1's complement and 2's complement to do that subtraction. Or I can call it an addition of a negative number. Alright, see you soon. Alright, everybody. So now, let's try to represent numbers in some different forms, okay? That's what we're going to do here. So if I write the number, let's just say positive, right? Positive 26, okay? Suppose that's the number. Why don't you pause the video and write down your binary value. Okay, and then restart it and we'll do it together. Okay, so let's try it. The method we generally use is we write the number 26, and suppose we have 8 bits, right? So this is 1, 2, 4, 8, 16, 32, 64, and 128. So we know that actually, since it's an 8-bit number and we have a signed number, this is simply your signed bit. I'm sorry. So this will be a 0, right? Because the 0 will represent a positive value, right? Now obviously 64, there's not going to be a 64 on 126. 32, there's not going to be a 32. There's going to be a 16 there though, isn't there? 1, 6, you subtract this and you have 10, right? You're going to have an 8. So if you have an 8, that comes to 2, right? You're not going to have a 4. You're going to have 1, 2 in there. And then 0. Alright? So there is your true magnitude. That's what it's called, true magnitude right here for 26. And let me just write that down. It's going to be 0, 0, 0, 1. Now here's a tip for you. When writing your digital numbers, put a space in. Group them in groups of 4. Okay, so here's 4, and then we have 1, 0, 1, 0. Okay? So, now with this one, that's your true magnitude. If we want to write the ones complement, let me take this out of here, okay? Let me just take that out of there. For ones complement of a positive number, the ones complement is simply the number. So let's just rewrite it. 0, 0, 0, 1, 1, 0, 1, 0. Alright, so that's the ones complement of positive 26, okay? The 2's complement is the same thing. It's just the true magnitude of the number, right? For a positive number, okay? So this is 0, 0, 0, 1, 1, 0, 1, 0. Got it? Now, let's write negative 26, shall we? Pause the video, and then we'll do it together. Okay, so now for negative 26, it's basically the same number, except your sign bit is now a 1. So it's 1, 0, 0, 1, 1, 0, 1, 0, right? So that is the true magnitude of negative 26, okay? Well, the only difference is your sign bit changed to a 1, okay? That means it's negative. Now, let's continue. We want to write the ones complement. So what's the rule for writing the ones complement of a number? Of a negative number, I'm sorry. You already know the rule for the positive number. It's just the number itself. So for a negative number, what you do is write the positive number. And I'm going to do that right here, okay? 0, 0, 0, 1, 1, 0, 1, 0. And then you complement each bit, which means when you complement something, you don't say, hey, great job. What you say, if it's a 0, it changes to a 1. And if it's a 1, it changes to a 0, right? So this would be 1, 1, 1, 0, 0, 1, 0, 1. Whenever there was a 0, I changed it to a 1. Wherever there was a 1, I changed it to a 0. Okay? So there's your ones complement of a negative number. It's not that complicated, is it? Right? Now, the 2's complement is even easier. You simply take the 1's complement and you add 1. I'm going to pad this with zeros, okay? So we know that 1 and 1, well, that's going to come out to a 0, and you're going to have a carry of a 1. So you'll have a 1 here, right? And then this is going to repeat this number. It's going to be 1, 0, and then 0, 1, 1, 1. Okay? There is your 2's complement, okay? That comes down here. All right? And let me just clean this up for you here so you have it. But you have to understand the method. That's really what I want you to understand here, okay? So we're gonna do another number, so don't worry. But there you have it, okay? You were now able to represent a number in its true magnitude form and in its 1's complement form and its 2's complement form, okay? Actually, I forgot to take this little 1 off here. Make sense? All right, I'm going to get rid of the 26's. I'll be right back, and we're going to do another example. See you in a minute. All right, everyone, welcome back. So the next set of numbers that I was going to demonstrate this on is 61. There's no reason for 61. I just chose it, right? So I could say 71 like I was driving down the highway, but that would not be legal, so we're going to stay legal in this class. That's too fast, right? So what I would like you to do is pause the video and give it a try. You know, we're going to use the same methods that we used on the prior example, and go through it, and then restart the video, and then we'll go through it together. Okay, see you in a minute. All right, everyone, welcome back. So let's first find the true magnitude of 61. I'll do that over here, okay? So I'm going to write 61, and we can just write 8 bits. Well, we know this bit is going to be a 0 because that's your sign bit, right? So we know we're dealing with a positive number, so since it's positive, it's a 0. So let's just write this 1, 2, 4, 8, 16, 32, 64, okay? So let's do our regular method here. Right, let's give it a try. So will 64 go into 61? No, that's a 0. 32? Yes. Let's see, 11 minus 2 is a 9. 5 minus 3 is a 2. Okay, 29, so 16, right? 9 minus 6 is 3. 2 minus 1 is 1, so we have 13. 8, right? That leaves what? 5, doesn't it? 4. Leaves a 1. There's no 2's in 1. There's your 1. Alright, so that's what I came up with. Let's just check it. So 1, 4, that's a 5, and 8, that's 13, right? 13 and 16, that's 29. 29 and 32, that's going to be 29, 30, that's going to be 61. Yeah, that's right. Okay, I always do it in my head just to check when I do something. You want to always check your work when you do it because it's so easy to make a mistake when you're going through this. We try to go through it fast, but just give a check to make sure when you're doing this, especially on an exam. It's really frustrating when you know how to do it, and you might go through it a little bit too fast and make a dumb error, and it carries all the way through. So be sure to check your work, okay? So let's write the true magnitude here. It's going to be what? 0, 0, 1, 1, 1, 1, 0, 1. Okay. Looks like we got it. Now I'm going to take this out of here now, all right? Just to give us some space. Now, what's the 1's complement? Same thing, isn't it? Because it's a positive number. What's the 2's complement? So, we got half of it done. Now, how would you write negative 61 in the true magnitude form? The true magnitude form, you simply change the sign bit, which is the farthest bit to the left, right? There you go, right? It's the exact same number, right? Except I just changed the sign bit to a 1. Now, let's do the 1's complement. I'm going to do the work right below it. So how do we do it? Well, we write down the positive number. I just wrote it down. It's the same number, right? Okay. Now, what do we do after we do that? We complement each bit, don't we? So this is going to be a 0, 1, 0, 0, 0, 0, 1, 1. There you go, right? Let me clean this up for you. But you know where it came from. I just wrote the positive value down and complemented each bit. Got it? Now, what's the 2's complement? What do? We just add 1 to the 1's complement, don't we? So here's a 1. And we're going to pad the rest of it with zeros. The reason why I pad it is it makes it easier to hold your place. You don't have to do that. It's just how I do it, okay? So now, if we add these together, we're going to have what? 1, 1, 0, 0, 0, 0, 1, 1. What do you know? I'm trying to bring this down for you right here. There you go, right? Okay, so now at this point, I believe you know how to obtain the true magnitude and 1's complement and 2's complement of a number. Next, we're going to go over how to use the 2's complement to perform a subtraction. See you soon. All right, everyone. So now what we're going to do is we're going to take the 2 numbers that we worked with and we're going to perform a mathematical operation. What I want to do is I want to take 61 and subtract 26. Okay? But let me write that differently. Let's say we want to take 61 positive, okay, and we want to add to it negative 26. All right? Conceptually, it makes a lot of sense, right? You're just adding a negative number. You know how to do this. We already went over that in our digital arithmetic. But this right here, this is what you're going to use your 2's complement for, okay? All right, so let me take this out of here. And let's just write it down, all right? I'm going to do it the easy way here. Once you get this, it's really not too bad at all. So first, let's write down positive 61. That's going to equal 0, 0, 1, 1, 1, 1, 0, 1. Okay? Now, let's write down your negative 26. You know how to get the 2's complement. So we're going to write down this value, okay? What I'm going to do here is I'm going to write down a negative 26. That's what we're going to be adding, right? Now look, this is the 2's complement form right here, okay? So I'm just going to put the 2's complement right here. Now what is the 2's complement? That's going to equal 1, 1. I usually do it from right to left, don't I? This is 0, 1, 1, 0, right? This is 0, 1, 1, 1. Okay. And we're going to add them, aren't we? Well, 1 plus 0 is a 1. 0 plus 1 is a 1. 1 plus 1 is a 0. We're going to carry the 1, right? 1, 1 is going to be 0. Carry the 1. 1, 1 is going to be 0. Carry the 1. 1, 1, 1. That is 1. Carry the 1. 1, 0, 1. That's 0. Carry the 1. 1 and 1 is 0. And we're carrying the 1, right? But since we only have an 8-bit number that goes into bit land, it doesn't matter, okay? So here is your result. Notice the sign bit is a 0, which means you have a positive number, right? So let's figure out what the number is. It's going to be 1, 1, that's 3, right? 1, 2, 4, 8, 16, 32, right? 32 and 3 is going to be what? 35, isn't it? It's a positive 35, right? Well, what's 61 minus 26? 11 minus 6 is a 5, right? 5 minus 2 is a 3. Hey, what do you know? It matched, didn't it? All right. Let's try a second one, shall we? But this time I'm going to reverse it. We're going to have 26 and subtract 61. All right? So we're going to take positive 26 and we're going to add to it negative 61. We're adding it, right? So let's see, what is positive 26? Well, we know what negative 26 is in the true value form, right? So we just don't call the first bit a 1, we'll call it a 0 to make it positive 26. So it's going to be 0, 0, 0, 1, 1, 0, 1, 0. Okay? Actually, I went left to right on that, didn't I? Well, let's check it. 1, 2, 4, 8. So this is 10. And 16, that's 26. Okay, that makes sense. What's negative 61? What do you think that is? Well, let's do it quickly, shall we? Let's just do it down below. We know that positive 61 is equal to 0, 0, 1, 1, 1, 1, 0, 1, right? That's what we have up here, okay? let's just check it. 1, 2, 4, 8. Well, 1 and 4 is 5, and 8, that's 13. 13 and 16 is 29. 29, 32, that's 61. We already went over that. Okay, so let's take the 1's complement. We need the 2's complement here, don't we? We need the 2's complement. So first thing we're going to do is we have to find the 1's. So to find the 1's, we write the positive number down, which we just did, and we complement each number, right? That's going to be right? And now for the 2's complement, we're going to add 1 to it, aren't we? So the 2's complement would simply be 1, 1, 0, 0, 0, 0, 1, 1. There's your 2's complement, right? So let's write it up here. 1, 1, 0, 0, 0, 0, 1, 1. All right. Now, let's try to perform the addition. 0 and 1 is 1. You carry the 0, there is no carry. 1 and 1 is 0. We're going to carry the 1. 1, 0, 0 is 1. Carry the 0, so there's nothing to carry. 1 and 0 is a 1. 1 and 0 is a 1. 0 and 0 is a 0. 1 and 1. Okay, now looky here. That's your sign bit. It's a 1. That means you have a negative number, okay? Here's a key point. When you add them, if your sign bit is a 1, which means it's negative, that means this value is the 2's complement of the number, okay? So in order to get the true magnitude form, you're going to have to take the 2's complement of your value here. So let's do it, okay? So if we take the 2's complement of this, I'm going to write it down here. I'm just going to rewrite the number down here to make it easy, just to give us some space too, you know. Now, first thing we have to do is write the positive number down. 0, 1, 0, 1, 1, 1, 0, 1. And then we're going to take the 1's complement of it, which would mean we would complement each bit. 0, 1, 0, 0, 0, 1, 0, 1. We're going to add 1 to it, right? Missing all these zeros now. It's going to be a 1, 1, 0, 0, 0, 1, 0, 1. So this is going to give you your magnitude, right? 1, 2 is 3, okay? 1, 2, 4, 8, 16, 32. This is going to be negative 35, isn't it? So that's what's expected, right? You know that the value there is going to be minus 35, right? The thing about this 2's complement that's important for you to remember, okay, is this is how machines work. They can have adder circuitry, and it's easier for these machines to add a negative number than to perform a subtraction operation that requires different circuitry. So this is how they do it, okay? It's using 2's complement. It's very easy for computers to complement bits. That's just an inverter, isn't it? And we're going to get into adder circuitry shortly. So those were two examples where you had 1 is greater the result was positive, and you had another one where the result was negative. Just remember, if your result is positive, you don't have to change it, because the 1's complement, 2's complement are all the same, right? That's what you have over here, right? They're all the same as your positive number. If they're negative, all right, you're gonna have it right here. You're gonna have to convert that negative number into 2's complement. You perform the addition operation. If your result is negative, which means your sign bit here is a 1, that means your result is in 2's complement form. And to go back to true magnitude form, you're going to have to write the number down, rewrite it, writing the positive form of it, complement each bit to get the 1's complement. This right here is your 1's complement form right here. You add 1, and this right here is your 2's complement form. Okay? This bit is your sign bit. This bit, these bits, these last 7 over here, those are your magnitude. Okay? And you already know it's negative because of this right here. But you needed to get the magnitude. Okay? Alright everyone, I hope this has helped you in your understanding of digital arithmetic. And I will see you again soon. Bye now.